In this question, for f of x equal to 2x minus 3, f to the minus 1 of x, the inverse function of f is equal to. So you have to find the inverse function, and the rule to find the inverse of any function is just to start by swapping x and y. So swapping x and y, you end up with, so this is y equals 2x minus 3. So swapping them, you'd end up with x equals 2y minus 3. And then you have to rearrange this to make y the subject. So adding 3 to both sides, you'll get x plus 3 equals 2y. And then dividing everything by 2, you end up with y is equal to x plus 3 on 2. And looking at the answers, which one? I think it's this one. So another way of writing this, when you have a fraction like this, you can separate it into two separate fractions like this, 3 over 2, and this is the inverse function f of x, f to the minus 1 of x, I mean. So, and just on going from that step to that step, if you have like 1/3 plus 1/3, that's really the same as 1 plus 1 on 3, which then becomes 2/3. So really you're going from this step to that step, going from here to here. So that's how you find the inverse of a function. Just swap x and y, then rearrange to make y the subject, and you end up with the inverse function. Which one of the following sets is a possible domain for the function with rule f of x equals x plus 3 squared minus 6 if the inverse function is to exist? So you are looking for the domain that will make this function be able to have an inverse. So here are the domains, and one of them will have a set of x values that will make this a one-to-one function, which is the main thing that you need to have, or it's the one condition you really need to have for a function to have an inverse. So it needs to be a one-to-one function. So first of all, I'm going to draw the graph. I'm laughing because it's like the second set of dodgy axes I've done on an angle. But anyway, so the turning point of this one, and it is a quadratic function, so the value of x that makes the bracket 0 is minus 3, and that's the x-coordinate of the turning point, and this number here, including the sign in front of it, is the y-coordinate of the turning point. So minus 3 minus 6 is down here somewhere, and it's an upright parabola, so doing something like that. And so here's minus 3 minus 6, so that x value there is minus 3. And right, so a one-to-one function. Now this function here is actually a 2-to-1 function because that horizontal line that is cutting the parabola at that point there, let's say that has the coordinates minus 6 comma 0. The y value is 0 at the x-intercepts, and let's say that one was 3 comma 0. And you can see from that that there are two x values, two different x values for that one same y value. So that is a 2-to-1 function, which is many to one. But it has to be 1-to-1 for it to have an inverse. And the way you make a graph 1-to-1, if it's many to one or many to many or one to many, is just get rid of part of the graph so that you basically just got a line going in one direction but not changing direction. So for example, you don't want it doing that because when you draw a line it's cutting at 3 spots. You don't want it coming back on itself in any way, because then when you do a horizontal line there you're going to get 2 points. So what it really means is you've got to get rid of half of the parabola or part of the parabola. So looking at these domains, first of all, a domain of R, so all reals, all real numbers. So that means x would go from minus infinity to positive infinity. So that would basically be the whole parabola, which is definitely not one-to-one, as I've already shown you. So A is not the answer. And B, minus 6 to infinity. And assuming again this point was minus 6 to positive infinity, to positive infinity would be from there all the way along the graph there, and so it would definitely not be one-to-one because it would double up on itself there, and you could cut another horizontal line there if you liked, and then that would not be one-to-one. So it's definitely not B. C, minus infinity to 3. So that's from here all the way past the turning point up to, say, this point here. And again, that is not one-to-one. So it's definitely not C. And D, positive 6 to infinity. So here's 3, 6 is up here, and it's not going straight up. It's supposed to kind of go out like that, in that direction. And from there, heading to the right towards positive infinity, that line would not double back on itself because it's just going straight up into the wherever. So that would be one-to-one, that part of the graph. So looks like D is the answer. And E minus infinity to 0 would be from this part of the graph up to the y-intercept where x is 0. So that little bit there is the graph doubling back on itself, and that would mean you could draw a horizontal line through it and it would not be one-to-one. So E is definitely not the answer. So D is going to have that domain that would definitely make this function one-to-one and would therefore mean that it would have an inverse function, or its inverse function would exist. So yeah, D is the answer, and that's about all you have to do for this question. This is not a lot of working out. It's really just looking at the graph and just checking out each of the domains carefully to see which one actually makes the graph one-to-one. And it's a typical exam question too, end of year exam question. So that's about it for this question, and I will see you in the next one.